Hello guys, today we are going to look at literals. What are literals in Java? Literals are fixed values directly written in code. So these are what we mean by literals, the values that you write. Today we are going to look at how you can modify these literals. So today we are looking at literals in Java. Simply, these are fixed values that a programmer writes. Like we have been providing types, then we declare our variable, then we assign values. So these are simply the literals that we assign. These are the simplest pieces of data that Java programs use. Yeah. So what if I want to modify these? Can I use is it possible for me to use besides numbers like plain numbers, integers, can I use bases, binary numbers? Let me start with base 2. It is very possible. While dealing with the literals, these values here, you can use any numbers that you want. It is very okay to use the bases. So let me start with, can I use base 2? Let me start with base 2. It is very possible. So you can write base 2. So I want to print out like, can remove this. Let me say I want to print out like numbers in base 2. I'll say, let me begin with 1. Let me print out this numbers in base 2. First print out 1 and we see. And compile. Yeah, you can see that we have used base 2 to print out the desired number that we want. Meaning by literals, I can use or I can play out with bases, any base that I want. But whole numbers. Let me say I want to print out like 10 in base 2. So I would say like 10, compile this. Then run. You see that 10 is being printed, but I'm using bases like base 2. This is very possible with other bases. Oh, let me say, let me use a big number. Big number I can say. Let me print out a number like 255. Yeah, let me use 255. I can use 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 200. So meaning here you can play with all different base numbers that you want. It is very acceptable here in Java. You can see that I have successfully printed out 255. Let me say, let me change to other bases to make this very possible. Let me say, let me change to which base would I change to? Let me change to Octal iterates. I'll use like base 8. Base 8, I'll say, let me first print out this 7, and I see it is very possible. 10 1. Yeah, you can see that I have successfully printed out 7 in the Octal literates, meaning base 8. Let me print out like, let me change to any bases that you want. Let me say hexadecimals. Yeah, that's base 16. See, I want to compile out number 15. Let me see. Compile, run. Yeah, you can see that I have successfully printed out a number in hexadecimal, which is base 16, but using the bases themselves without using the actual number. So simply these are literals in Java. Let me deal with other literals. Let me use like scientific notation. Scientific notation while dealing with float numbers or double. Let me use float. Let me use double. And I say give this a new scientific notations. So I'm just trying to show you that you can change any value here, the literals. You can use anything and it will be compiled successfully. Those are some of the powers that, actually these are some of the recent changes that Java made. that Oracle made to Java, that you can insert any literals here and they will be compiled successfully. So here I'm going to use a scientific notation. I'll say something like 1.234 in a number 6, and use E scientific notation, then this, then close. Let me print out this, and I see compile, run. You can see that I have successfully printed out our number, but in the scientific notation. Yeah, so thus let me deal with other numbers. Let me say that was double. I can say float. Let me say my literal float. You can say this is equal to, let me say 977, and a number. Change this to notations, and let me say like 10. Then remember, if you're dealing with float, you end with, have to tell Java that I'm not using double, I'm using float. So I can say print my literal, and then compile, then run. You can see that I have successfully printed out a large number using the E notation. It has helped me to produce a large number over more than 14 decimals. Yeah, so let me deal with some characters. Here I have successfully dealt with float, integers. So let me deal with characters. Let's see. So I use char, then I'll say my first name. Remember, characters take a single letter, and you don't use double quotes, you use single quotes. So I say like C is like C, then terminate. Try to output this here, and I see the output literals. Compile, then run. You can see that I have successfully printed out C. Yeah, so I can also modify this. I can increment C. Yeah, how do you see that I can increment this number? So in Java, we have what we call the incrementation. So I can say my first plus plus, then terminate. So what I'm doing here, I want to increment by 1, but on my character. Let me print out this, and when you say plus plus, you are meaning you want to increment only one digit to your variable. Remember, this is C. So let us see our outcome. You can see that C, then D. Meaning here, if you have like 1, and you are trying to use this incrementation, compile this, then run. You can see that I have incremented by 1. If you use the incrementation notations in Java, you are incrementing your variable by 1. You're adding by 1. You're adding 1 digit ahead. So let me deal with. So I have seen, okay, the booleans. I'll say my first my boolean. My boolean. This should be true. Can't be another number. Either true or false. So let me compare this. Then run. You can see that I have successfully printed out my literal, this one, out. There is another interesting thing that that was released in Java. Let me say you're dealing with a number with many zeros. I also get issues with those numbers that have many zeros. Yeah, so how can you deal with that? I'll use integers. I'll use an integer. For a simple example, give this a variable. my number. Okay, use my number. Then use, say, like we are dealing with this number here, and it has many zeros. I also get issues with dealing with such numbers with many zeros. So in Java, there is this nice thing that they introduced. You can use underscores between numbers here. Yeah. So you will see that uh, this an integer. We are out of range. You can see int is out of range. So I just have to come here, reduce on the zeros. So I can use this, the underscores between zeros. The outcome will be the same, but at least here, now I can understand that this is 1 million. But if the underscores were not there, it becomes so hard. So compile, then run. Hey, sorry, I'm still printing out my boolean, so I have to print out my number. Do the same, compile, compile, run. You can see that the same number is here, but at least here I can distinguish. My number has been printed as it is, but here at least I can know that this is 1 million. Yeah. Why using underscores? So simply those are literals in Java. Here, these are data types, these are variables, now these are literals. So that's literals for you. Thank you guys.